Hi, this is Mark Kemper with EMS, and in this video, we're going to 3D scan some holes. Okay, so to get started, let's talk about what we're trying to achieve here. What I want to do is I want to 3D scan holes and take more of a scientific approach to scanning them. And the application here could be both reverse engineering and inspection. But for inspection, it's really important that you can get good quality data in a hole if you're trying to accurately inspect holes on a part. So what we're going to do is we're going to try 4 different model Creaform scanners, and we're going to scan them in the different modes available. So for the laser scanners, you have the cross laser line mode and the single line mode. So does the single line mode, for example, make a difference? Can it get deeper into a hole? Do you get better quality data? Things like that. And then for the GoSCAN Spark, we're going to try the auto shutter mode and the manual shutter mode and see if that makes a difference. And what we're going to do is we're going to scan, and what we did is we have this plate manufactured, and it's got holes starting at a 1/2 inch in size all the way down to 0.06 or 60 thousandths of an inch. And we're going to try scanning all of them along with their corresponding slots and look at the data. And we're going to go in and measure for each hole and slot how deep we can get in the different modes with the different scanners. And then we're also going to cut a cross section through the data and see how the quality is. Because the requirements for inspection are far different than reverse engineering. For reverse engineering, if you can't quite maybe get a hole, you can always take some manual measurements and get some, and create the CAD you need. But for inspection, you can't do that. You really have to get good data in that hole to be able to measure it. So we're going to test the HandySCAN 700, the HandySCAN Black, the GoSCAN Spark, and then finally the MetraSCAN Black. And we'll go through each one, and we'll, like I said, analyze and really look at the data to see what the differences are between the different scanner models and the different modes, and see how they do. And we'll start with the HandySCAN 700. All right, so let's talk about kind of the ground rules here for our test so that we can try to do as fair a test and even of a test across all the scanners. So first thing is we've just set up this little rig right here. We're going to set the part on here to go ahead and scan. Just putting it on 3 posts like that. We've got our little geodomes around it just for targets, because obviously most of these scanners require targets. And if you're not familiar with this, in the link below, there'll be a link to the CAD file. These are basically just 3D printed out, and they've got a recess on the back so you can put a magnet on them, so they're great to stick around. And they're really nice when you're trying to get around corners and stuff like that. Of course, we have the triangles. I think everybody's seen those. But these domes are really nice, and we use these a lot. And I've decided to use them here because we're just kind of more scanning down onto the part. I don't have to get so vertical like we do on other things. But we're going to go around and scan the part. Now, again, to make everything the same for all the scanners, we're going to set the resolution at 0.3 millimeters. That's spacing. That's not accuracy. That's just the density of the mesh. So we'll go about 0.3 millimeters, and we've turned off all what I call the nannies. So that's the post-processing of smoothing the data, sharpening the corners, filling in holes, et cetera, et cetera. Because usually when you're doing inspection, you do not want to be doing that. You don't want to manipulate the data in any form. And the primary application here is inspection. Of course, like I said, with reverse engineering, it applies, but with reverse engineering, you can get away with a lot more if you just can't get good data on a hole. But if you don't have good data on a hole for inspection, you're out of luck. Also, we're not going to apply any kind of dust or spray or any kind of finish on these developer spray, those types of things, on this part. And the reason being is because in the real world, if you're inspecting a lot of parts, you're not going to be spraying any kind of spray on parts like this. First of all, it's messy. You get fallout from it, so then you're taking it outside. It takes more time. It adds thickness. So we want to do a real world test where we might be doing some short run production, and we want to scan the parts as is, okay? So we'll see how that plays in with some of these different scanners, okay? And we're just going to go around and scan until we just feel we can't get any more data. This is not a time test. It's also not an accuracy test. We're not going to measure for accuracy. We'll be able to tell when we cut sections the quality of the data if it looks like it's good quality. But we've got other tests, accuracy tests and speed tests. You can check those out. And then also, if you're not familiar with these scanners, every one of these scanners, we have an in-depth 20 to 30-minute video that goes into everything about that scanner and how it works. So if you're not familiar with these scanners, I'll put some links in the description below and you can go watch a detailed demo. But let's get started. Like I said, 0.3 millimeters, we're setting the spacing. The accuracy is whatever the accuracy of the scanner is. It always scans at the highest accuracy. So to get started, I'm just going to go ahead and click the button here, and I'm just going to work my way around the part. Okay, I'm going to start by, and I'll zoom in here a little bit. First, let's just capture kind of the basic shape, and then we're going to work around. And we'll start in just the cross mode or crosshair mode. Basically, in the scanner is a prism that splits the laser into a cross mode. So this is the HandySCAN 700. It uses 7 lasers, which is split into 14. As I've said many times, it's all line of sight. As I've said, you can't overscan the part, so you can keep going over and over the same areas. It's not going to hurt anything. In this case, it's preferred. And my angle of attack, I'm just going to work around these parts at all different angles, trying to get in there, because the way this works is these two sensors come out and they converge and they're looking for that laser line, okay? So if it doesn't see the laser line, it's not going to pick up any data. That's why it's really important to move around and try to get as much data as possible. Of course, I'm using our rotary table because that just makes life easy for this test. And I'll just go around and scan as much as I can. Now, of course, on the smaller holes and slots, you're really going to have to spend some time to get in here and get the data. Now, one thing, if you're looking at the data on the screen, we're in a lower res mode, so we can do this kind of rendering on the fly as we're scanning. When we get done scanning and process, that's when the data will look much better. But for the purposes of being able to kind of show you on the fly what's going on, it's always at a lower res, okay? So again, I'm just going to keep going around each one of these. And then for the single line mode, I'm just going to, we would save this file and then start over and then, or add the single line mode. And the single line mode is a single line. It's oriented a different way, and the cameras are zoomed in and really just looking at that. So certainly on the smaller holes, we're going to spend a lot of time on that single line mode trying to get in there and get that. So we're going to go through and do all the different scanners, pretty much imitating this process each time. And again, it's not a time test, it's not an accuracy test, it's how much data can we get, and we'll do it until we just feel we can't get any more data. Okay, next up we're going to use the Creaform HandySCAN Black Elite. One thing I should also mention is we will adjust the laser power for each scanner to scan this part, and that's something easy to do, and again, you can watch in the demos. But again, we're just going to go around. Now, the HandySCAN is blue lasers versus the 700, which was red laser. And what blue laser does is it just gets better a return back to the sensors, especially on challenging surface parts, dark and shiny. This part's aluminum. So blue, is supposed to work better in those conditions. And of course, we're going to measure all this data. So let's see if the blue laser actually does better. So again, we'll scan around, we'll save it in just the standard cross laser mode, and then we'll continue scanning in the single line mode to see if we can pick up more, and then we'll save that as a separate file, and again, we're going to measure them and then look at the quality of the circles or the diameter. But same process, just move around the part and get as much data as I can. All right, next up is the GoSCAN Spark. Now, the GoSCAN Spark really isn't designed for inspection, although you could use it, but it's certainly used a lot for reverse engineering, and we always want to try to get the best quality data in holes or slots. So let's just see what it can do. Now, the way this scanner works is it has 99 single lines, so it's kind of like it's always in single line mode, but it works differently than that. So we'll go around, we'll scan this part, and we'll start in what's called the automatic shutter mode. What that's going to do is it's automatically going to adjust the power of the lights for us and the speed of the sensors as far as collecting the data. And then we'll do the manual where we'll override it to what we think is a good choice and see if that gets us any more data. So we'll just basically do this part twice in those two different modes. Of course, spending time on these smaller holes and again, getting from all different angles to try and get as much data in these small holes and slots as possible. Okay, next up is the MetraSCAN system, and we'll go ahead and get started with that and just move around. The MetraSCAN works completely different, and again, if you want to see videos on how each system works, I encourage you to check out those links in the description below. But we'll again just move around the part, scan everywhere we can, and also use that single line mode as a second step to try to get into all the data. Now the other thing with the MetraSCAN system is you have the ability to do probing, okay? So this is a handheld probe, and the advantage of probing when you get into really small holes is you can take this probe tip, and even though it won't fit down into the hole because it's so small, I can at least center it on that hole, take a point, and at least get the center of the hole for, like, you know, positional measurements, positional tolerances, things like that. So on holes, this is a 3 millimeter tip on here. I think you can go down to a 1 or 2, so you could actually get a smaller one. But obviously on the bigger holes, we can get in and measure those holes, and then at least on the very small ones, we can drop in and get a center point. So that is one advantage of the MetraSCAN system, is you have scanning and probing, but we're not going to look at the probing for this test. I just want to point that out and, you know, let you know that that is another option. And then finally, let's talk about threaded holes, because these are all through holes. Threaded holes present a totally different challenge, and for those you would use something like what's called a true pause, where you thread it in and then it's got a cylinder that sticks up out, and you 3D scan around that cylinder, and then you can get the again, the positional tolerance, or the center of that hole. But trying to scan threaded holes for any kind of measurement of the hole is very difficult, so you really can't do it, but you can at least get the positional tolerance. So that's all of the scanners. Let's go ahead and take a look at the results and see what we have.
Okay, so taking a look at the scan data and what we did and how we analyzed it, what I've done is I've brought in all of the scan data from all the scanners, and I've basically stacked them all on top of each other. And if we turn them all on, you can see here. So we've got them all stacked up on top of each other. And what we're going to do is analyze one at a time. And what I've done is I've created a section right through the center of the hole, or a plane, right through the center of the hole and the slot, okay, for each one. And as you saw, here's the original CAD model. We've just numbered them 1 through 8 just for reference. And so we can hide the CAD, turn back on the scan data. So we've got that section cut through. And then what we also did is we cut a section just down, you know, under the surface a little ways. And what that is for is so that we can cut the section through and analyze. You see it right there. Cut the section through, a cross section through, and analyze the quality of the slot and the hole. And you cut down in because you don't want it right at the top where you got, you know, kind of a little bit of a radius, because no scanner can, you know, scan a sharp corner. So you want to cut down in a little ways and see if we can get a, you know, what the cross section looks like. Will we have a hole or a slot? Which would be indicative to the ability to find the positional tolerance and then measure things like, you know, cylindricity, things like that, okay, for inspection. So let's start with one of these. And so what we did is I'm going to just do a clipping plane and clip away the scan data, and let's hide the planes and the vectors, which were just the center of the holes. And what we did is we just looked at each one of these and we analyzed the scan data and we measured it. And what we were looking for is how deep we could cut. So I can measure a section, and I'm doing it in the z-axis here. So, you know, this one obviously cuts pretty much all the way through the hat. This is a 1/2 inch thick plate, you know, and same with here. It pretty much cuts through the whole thing. So, we can safely say that, this half-inch hole, isn't a problem. We can get data all the way through. But let's jump down to, let's do a new clipping plane, and let's jump down to, let's say, number 6, and we will take a look at this. So if you look here, you can see, the data doesn't, both in the hole and the slot, is a little rough. So what we want to be able to do is measure down, and really what we're looking for is where the kind of the deepest is you'd be able to still cut a section, right? So we wouldn't measure all the way down to this point. We wouldn't measure this point. Kind of right through here. So let's measure about, let's say, right there, okay? And we'll sample a few measurements through here. But what we're looking for is, how deep can you get and still cut a cross section through here and see that it's a slot or a hole, okay? So, you see here it's about 0.24 inches. And then same with here on the hole, it would be about 0.186, okay? So that's how we determine the depth. It's not the absolute deepest point. It's more of, what you can resolve with the scanner and still get a cross section, okay? So for example, that was, 0.25 there. Let's go down and cut just to take a look. Let's go ahead and cut a section through slot 8, which would be, of course, the smallest hole, the 0.06. And let's take a look at that for a minute, just so you can see. So again, that's where it really starts to become a challenge. So how far into, for example, this hole can we get? Let's turn it on and measure. So we'd measure from the top to, maybe about 0.07, where we can still get data around it. And then if you took a look at the slot, it might be about right there, 0.1. So that's how we kind of determine. We check different spots, cut sections through all the different scan data, and looked at it. So let's take a look at one more real quick. So we broke this up by the different scanners. So for example, let's look at the Spark, and let's maybe look at the manual shutter mode. So if you look here, you can see it really struggled with that really tiny hole. And maybe even a little bit with this slot, okay? So that was the methodology to cut the sections through the slot and the hole. Let's bring up just one more here. Yeah, let's look back at, let's say, slot 5 for a second, okay? And again, we'd go in there and measure that, okay? So we did that for every set of data. And then what we did for the cross sections, let's turn off this one. What we would do, and let's clear our clipping plane, okay, and bring up, turn all of these off, okay. So then we had this cross section, okay, and again, that's the one slightly cut in down from the top. Then what we did is we did a mesh sketch, which cuts right through the scan data, okay, and took that and analyzed the scan data. And what we're looking for, we'll hide the mesh, is, is it resolving a slot? Is it resolving a circle? For the most part. And you can see on this scanner, which is the 700 with single line mode, just about all the way down, it looks pretty good. Starts to get, maybe a little bit questionable on this hole. It's not quite round, okay? And we can even check the roundness of the scan data by fitting a circle through it and then measuring it, okay? Using our accuracy analyzer and using our multiplier. Right now we're set for 4 thou, just to see how perfect of a circle it created. So we went through and looked at these to try to determine, hey, how does it look, okay? It's never going to be perfectly round. We're scanning a manufactured part, but as long as it was within a reasonable tolerance, we could say, yeah, that hole looked pretty good. So if we take a look at this one, it might be a little bit too much, but it's still within 2 thou, okay? So that's how we kind of analyze the cross section to determine, hey, are we getting good data in there just below the surface? Now we also did the same thing for the slots. So if we come in here and look at the section and we just go to our slot tool, and for example, we just window in, it's going to fit a slot through that data. And also we can do that accuracy analyzer and see what kind of accuracy. And if we're within a few thousandths of an inch, we're going to say, hey, that's pretty good. And again, some of this gets into the accuracy of the scanner and the part itself, and we're not going to go into a lot of that, but does it look like a slot? That's just the purpose here, is can we get the data, and is it reasonably good data? Okay, so that was the slots along with the holes. So we did this for each one, and we recorded all the information, and then we put it in some charts, and we'll show that next, and we'll talk about it. Okay, so now what we're showing here is by taking all those measurements, we put all that data into some spreadsheets so we could create some graphs. So if you look at what we have here on the hole measurements, hole 1, hole 2, hole 3, all the way to hole 8, and then we've got some colors corresponding to the scanners for each one of those holes. So, for example, the HandySCAN 700 and the HandySCAN 700 with single line mode, that's going to be your orange and gray. And then your next up is the HandySCAN Black and the Black Elite next to that. And then next to that is the GoSCAN Spark and then the MetraSCAN. So we'll kind of skip over the larger holes. It's pretty obvious. But let's start here. So you can see here 700 in the orange and then the 700 with the single line mode. So you can see the difference. And this is depth over here. So we got hole number and depth. How far in? Again, picking that average, not the deepest point, but the deepest point you could still cut a circle through and get data, okay? So you can see here. And then this is the, next up is the GoSCAN. I said HandySCAN Black. GoSCAN and the with auto shutter and manual shutter. And manual shutter is just cranking the power up a little more. So we're just getting a little more data. And then next up was the HandySCAN Black, and then the Elite, and then the single line mode, and then finally the MetraSCAN, and then normal cross mode and single line mode. So you can see just general trends. HandySCAN overall does pretty good. GoSCAN not too bad until you get to the very smallest hole, which you can see down here. It just can't resolve just because of the resolution of it. But generally HandySCAN a little better than the GoSCAN. And then the HandySCAN Black is a little better than the HandySCAN and the GoSCAN Spark. And that I would attribute to those blue lasers, just being able to get down and get a little more data. And then the clear winner in most of these was the MetraSCAN. And I think that is because the the cameras are closer together and it can see down into narrower patches. Okay. So pretty interesting, and it does confirm the single line mode almost in every case gets more data. So if you go into that single line mode, you will get more data down in those deeper holes, okay? And, you could do the math on these, but I would say, maybe on average 15 to 20% more data by using that single line mode. And if you have the GoSCAN using the manual mode to adjust the power, does seem to get you a little better in most cases, okay? So that's the holes. And if you take a look at the slots, you can see that we definitely get, well, of course, the bigger holes are maxed out, but we definitely have higher numbers all the way across the board, meaning deeper. We can get deeper into the holes. And a lot of that has to do with being able to kind of scan down the slot. You're not as restricted, so you can get in, you have more angle to get into the slots. But, same general trend. No single line mode, single line mode, no single line mode, single line mode, no single line mode, single line, auto versus manual. So again, the clear winner is the MetraSCAN, just because of the configuration of those cameras, sensors being closer together, followed by the HandySCAN Black, which is the blue laser, followed by the HandySCAN with the red lasers, and then of course the GoSCAN Spark. So, overall, no surprises other than the MetraSCAN. I kind of thought that might be the case, but you just don't know till you try things out. But, clearly getting into those smaller holes, it, really did a good job.
Okay, so that wraps up the video on 3D scanning holes and slots. So hopefully it was informative and you learned something. And overall, if you look at these systems, they all did pretty well. The HandySCAN 700 is a great value, so the performance based on its value is exceptional. It did a great job in scanning the holes and slots. The GoSCAN Spark did pretty good considering this is not its main purpose in trying to scan really small detailed stuff and do inspection. But overall it did pretty good considering it's for industrial design, it can scan color, it's very fast for large things. Overall pretty respectable. And then of course the HandySCAN Black Elite is an ISO certified and measured to a VDI VDE standard with incredible accuracy and detail, did exceptionally well in this test. And then finally, the MetraSCAN did the best overall, and I contribute some of that to the fact that the actual sensors or the cameras are closer together than on all the other scanners. So I think that allows it to get deeper into the holes and see farther down, because basically the closer they are, the more of a shallow or narrow area they can see in. And of course, the MetraSCAN also has the probe. So if the hole just gets so small, probing is always an option you would have with this system. But overall, all of them did great. Of course, they're all at different price points and complexities, and that's something you'll have to look at when you're trying to maybe decide what system is for you. And if you'd like to learn more, if you'd like a personal demo on your parts, some kind of benchmark, we'd be happy to do that. And we can do that in person, we can do that via the web. There's many different ways we can do it. And if you'd like to learn more, you can call us at 877-845-2700, or you can shoot us an email at info at ems3d. And then also below in this description, in the link, there'll be a link below in the description of a quick contact form. If you just want to click that, put your name and info in there, and we'll happily reach out to you. But this wraps up the video on 3D scanning holes.